Erik Darling here with Darling Data, and today's video we are going to go over a little bit of the material from my T-SQL course. The usual spiel about this stuff. It is on pre-sale right now. The course is completely written at this point, just finishing up the last bits of tech review and tidying up, and I've already started recording some of the already done content, so that'll start appearing over on the training site in the next week or so. Of course, this is the companion material to the stuff Kendra and I will be teaching at Past Data Summit. If you're attending the pre-cons in Seattle, then you will get free access to the material. If you're not attending the pre-cons in Seattle, you get nothing. You have to buy it just like everyone else. Once the material is fully published, of course, it will be going up to the full price, which of course will be double the pre-sale price. So get in now to have half the regret later on. Who knows what you could have done with the other half of the money that would have been good for you. You could have bought so many lottery tickets. Anyway, we're going to talk a little bit about order by. And if you find yourself watching this material and saying, yeah, Erik, I know, well, congratulations. This is the beginner material, and you just might not be a beginner, which is wonderful for you, right? But for those who have not yet progressed to your lofty place in the T-SQL world, this sort of education is necessary. So we're going to talk a little bit about order by, and specifically non-deterministic order bys. And then, of course, expecting queries to return in a specific order when there is no order by, which is another thing that people tend to do. They observe a query running and returning results in a specific order, and then if it ever doesn't return the results in the order, they freak out and they're like, oh, but it was all this way before. So do that a little bit. So first, query plans are turned on. Look at that, baked right into the demo. You'd think I've been practicing or something. If we run this query a few times, what we're going to see is sort of in general, the results, like just over here in the ID column, are going to come back in all different orders. And of course, the reason for that is that this particular sort order is non-deterministic. The reputation at the beginning part of the index, or rather at the beginning part of the values, there's no index on reputation currently, the beginning part of the values for the reputation column are all ones, right? And so all we're doing is ordering by the ones, but the ones can come back in any order that they want, right? As long as they're just ordered over here. So if we keep running this a few times, we're going to notice that the ID column flips around quite a bit, right? This looks different from the last one. We run this and just keep running it. Now -1 is at the top. -1's still at the top with some other stuff switched around. All right, we just keep doing this over and over again. We're going to see just like different results depending on like threads and timing and all sorts of things. So if we want a deterministic order by, if we want to always present results in a specific way, we need to incorporate a unique column is sort of a tiebreaker to our order by elements in here, right? So we need to add in this case, the ID column from the users table, which is the clustered primary key, right? So if we run this, then not only are we ordered by reputation here, but in order to tiebreak the ordering to make sure this is deterministic, now we order by the ID column as a secondary element. So we order first by reputation, but then for duplicates in reputation, we order by ID. And this will return absolutely stable results every single time. We can't mess with this ordering because of the uniqueness of the ID column. Now, this behavior can be sort of misleading to a lot of people. If their data doesn't have a lot of duplicates, just some duplicates, right? So if we flip the ordering of reputation and we just say order by reputation descending, then there's not a lot of overlapping values at the top of the food chain here. The reputation column is like largely like once you get up this high, not a lot of people have like duplicate reputations where you would need a sort of tiebreaker thing. So you could observe behavior like this working quite well for a while, but then after a certain point, you are going to start hitting duplicates and things might start flipping around on you. So just for example, the first reputation at the high end that I could find that had a duplicate value when it was 160303. And sometimes this takes a few runs to kind of get to work correctly. But here you see the reputation 160303 at the very top here. I don't think there's any other dupes down below, but you see IDs 206403 and 19679. If we just kind of run this enough times, you'll see those two columns flip back and forth. And that's because they are duplicates. And so SQL Server only has to return this thing in order to a certain point, but within duplicates in there, it can return those in any sort of flip-floppy way that it wants, right? We don't know which one we're going to get back. This might not seem like a very big deal to you in this pretty narrow case, but I guarantee you, at some point in your T-SQL developer career, you are going to have someone file a bug report and say something like, hey, I'm getting weird results back here, and you're going to have a non-deterministic order by somewhere in your query that is messing things up for everyone. So let's just look at a quick example of where you might see like just the results change if your database changes, right? So let's pretend that for years we had this table and this query, and every time you ran this query, I've got a couple index hints on here just to make sure that, just to show you what happens when we use different indexes. So this first query is always going to be hinted to use the clustered primary key on the post table. And this query is always going to be hinted to use the non-clustered index last editor display name on the post table. That's the index that we created right here on last editor display name. It's very, very explanatory. There's almost nearly self-documenting if you want to feel special about it. But let's just say that for years we had this query running, and every time this query ran, we got results in a specific order, and everyone was happy. And at some point, someone was like, oh, well, there's a missing index request or something. And so we're going to add this index, and SQL Server is going to use this index, and we're all going to be thrilled. And if we run this, just run these back to back. Well, let's zoom it, getting a little weird on me. You'll see that these two queries return data in very different orders, right? If we just kind of make that about half and half, we just get this stuff back. Like these two result sets are just way different, right? 5, 2, 2, 2, 2, 3, 4, 2, 2, whatever. This one, 2, 2, 2, 2, 3, 2, 2, 4, 18, 4, 2, 16. So we just got way different results back, running the same query, just using different indexes. If we look at the execution plans, we get some sense of why. Well, we do an index seek into the post table here, and then we do a hash match aggregate. And of course, hashes, when you see a hash, there's absolutely no ordering required for that, right? Hashes just mush everything together and throw it along to the next thing. And then in the second query, we do an index seek into the non-clustered index, and then we have a stream aggregate. And stream aggregates do require sorted data. If we have we didn't have an index on last editor display name and SQL Server chose a stream aggregate, it would have to pre-sort the data for us. In this case, we have the index though, so we're good there. So SQL Server just streams the results into there and shoots it along to the next operator, the filter operator. But in both of these cases, neither one has an order by, but they both return results in slightly different order because the query plan is different and they use a different object to initially access data in the table. So this is the kind of stuff that you're going to have to deal with as a T-SQL developer, as you're writing queries, as you're troubleshooting bugs and results and stuff. Non-deterministic order bys, or just expecting results to always return in the same order no matter what without any order by whatsoever. Two very, very big mistakes that people make quite a bit. Anyway, thank you for watching. I hope you enjoyed yourselves. I hope you learned something. I hope you will consider purchasing this course on for the pre-sale price. The link is down in the video description. If not, I will see everyone who is going to get this for free at Past Data Summit, I guess in November. Anyway, thank you for watching. Goodbye.